So we're going to find the inverse of quadratic functions. Does everyone see what's been due? Everything besides the quadratic crash course assignment is in your in the grade book, and whatever you turn in on Friday, I'm still working on getting into the grade book. So does everyone see right here in green? Hey, in green right here that we're having a quiz on Friday over this stuff we're learning today. So again, if you want to do well on Friday, you got to prepare right. Okay, you don't want to be like some people and not prepare for the big day and then not be successful in the very important moment that they should have been successful at, but they didn't prepare. Oh, okay. You know, we can learn from other people who don't succeed, you know? I want to be like them. You know what I'm saying? When they play a big football game, you gotta be better than that. You gotta prepare better. I want us all to prepare better. Okay, so that being said, well, everyone look up here. So now, first step, it says we're solving for y. I need to get y by itself. So look right here. There's two things that I could get rid of on this side. There's a squared and a 5. If I'm going to get y by itself, what do you think I get rid of first? Okay, we usually say we get rid of the loner first. Would you agree? The plus 5 is by itself, so we're going to get rid of that loner 5 by itself first. Okay, how do I get rid of a plus 5? Minus 5. So we'll put that on both sides, right? Here we go. Minus 5, minus 5. It cancels out on the right. And so now I just have x minus 5 equals y squared. Now notice that minus 5 and that x, they do not combine. Okay? By the way, so x minus 5 equals y squared. Y is almost by itself, but I got the squared I got to get rid of. How do I get rid of that squared? What is the opposite of squaring something? Now here's a little clue on your calculator. If you look at the squared button, what is right above the squared button? Between them. That little, what's that little symbol mean? Square root. So square and square root are opposites. They cancel each other out both ways, right? So if I say what's the opposite of square root, it's square. What's the opposite of square? Square root, right? So check it out. When you get to the part where you just have a squared, you're going to square root both sides. Let me zoom in here. So I'm going to do square root of all this, and then square root of all this. That keeps it equal on both sides. And when you square root a square, they cancel out. So this goes away, and this goes away. Now we just have y. Okay. So y equals the square root of x minus 5. So is y by itself? It is on the right-hand side, so you're done. Okay. The only other thing you could do is maybe like switch it around so it looks like y equals. That's the same thing. Flipped around. So that's it. That is solving for y. So sometimes when you have a square, you have to have a step where you do a square root. Okay? I don't know if you've solved one like that before, but you definitely need to be familiar with it today. That's why I'm trying to make sure everyone understands, not just listening and potentially just copying. I want you to understand. Look at number 2 here. Same idea. I want to solve for y. Now, there's a lot of stuff on that side. What do you think I should get rid of first? This minus 3, this squared, or this 7? What goes first? 7, because it's by itself. It's the loner. So how do I get rid of a plus 7? Subtract 7. So minus 7 here, minus 7 here. And remember, it goes after the x. Okay, so this cancels out over here. All right, I'm going to bring this down. X minus 7 equals, parentheses, y minus 3, parentheses squared. Okay, I'm solving for y. What do I get rid of next? Do I get rid of the minus 3 or the squared? Well, what do you think? Squared? What do you think? Okay, so here's the deal. -3, you can't get to it yet because it's kind of like stuck inside of a parentheses. So you're kind of like doing like backwards PEMDAS. You're like trying to, the parentheses is the last thing you do, okay? So we have to get rid of that squared. We cannot touch the -3. How do I get rid of a squared? We just talked about it, square root. So let's square root both sides. Here we go. Square root this side, square root this side. Okay. Now I want you to notice on the left side, the square root is over x minus 7. On the right side, the square root cancels out with the square. Now I just have y minus 3. And on this side, I have square root of x minus 7. All right. Now, y is not by itself. I still have that -3. How do I get rid of that -3? +3. So let's do that. +3 underneath here. And then +3 over here. Now, please be careful. Everyone's looking. This is where people goof up. This -7 is under a square root. This +3 is not. So just like before, you're going to put that after, okay? So I like to show my little arrows, okay? This is going to go after the square root sign right there. So here's how it's going to look. Ready? I have the square root of x minus 7, like I did before. And then after the square root sign, I'm going to put the +3. Do you see? The 7 is underneath, the 3 is not. You cannot just randomly add them together, okay? That's very, 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 very important. Okay? Now, on the right side, everything else is canceled. All I have is y, and that's it. I solve for y on both sides. Okay? So that's probably the most complicated looking one. So this one's kind of straightforward. That's probably the most complicated. Could you do stuff like that is the question, okay? If the answer is no, then we're going to have to get with the program, because today we're doing notes on inverse quadratics, and you've got to be able to do that. That's like part of, for sure, what you have to do today. Real quick, that first. Go ahead and try to focus on that first, get out of the way. All right, here we go. Got the 5.2 notes. The objective, it says, is to define an inverse function and then find the inverse of a given table, graph, and equation of a quadratic function. So check this out. This, hey, everyone look over here. This is on your notes. We did quadratic crash course last week, so you know what this looks like. It looks like a U shape. It's a parabola, right? And then today, we're finding its inverse, which is this thing, a square root function, okay? Now, notice on this table, it says NA, that means it does not exist. Like, there's nothing there. So here's the deal. You could graph, both of those, and this is on your notes. X squared looks like this, and then square root looks like this. Now, think about it. What's similar about both of these? Is there anything similar about them? There. Okay, they both go through the origin, 0, 0. What about their shape? What's different? What's the same about the shape? Okay, it's a curve, and it's actually the same exact curve. If you look at the first one, it goes over 1, up 1, and then over 2, up 4. over 1, 1, over 2, 4. Okay? It's literally the same graph, except it's done this. What's that called? It's a special, like when you do this. Mr. G is doing what with this stick? Rotating. Okay, so rotation. Okay, turning maybe would be a word, but rotating. So this has been rotated 90 degrees technically. But what is different? So if I just rotated this 90 degrees, how is that different than this? It's cut in half. You'll see that? So basically, if you cut this first one in half and then rotate it 90 degrees, you get this thing. Okay, that's how it is. So here's the deal. The weird part about today is that because this is only half, we're gonna have to end up cutting the original one in half to make it match. Okay. So at the bottom, here's what we're gonna do. We're gonna graph. Okay. I want you to plot not these points, but half of these points. So I want you to plot that. Okay. So see this blue one? Go ahead and plot this blue one at the bottom on your little graph, right? Down here. Down here. I want you to plot this blue points 0, 0, 1, 1, 2, 4. Okay? And label it f of x at the bottom. Right? Bottom. If you take those points and you plot the inverse points, you end up getting those purple points. We call it the inverse. That's why it's got a little -1. Okay. Now, if you remember from 5.1, inverse functions are symmetrical, or they reflect across the diagonal line y equals x. So I'm going to make a dashed y equals x line. Wouldn't you say that those two lines, even though they're kind of like curved, they reflect or are symmetrical across that diagonal line, right? Now you can write down this part in yellow too, if y'all are with me here. You got to restrict the domain of the original function, which means you got to take that blue original function and cut it in half, because when you flip it, you're only going to have a half. Okay? When you inverse the original, they must match. Okay? So the inverse is a function. If you remember Algebra 1, a function passes the vertical line test. A line cannot go through 2 points vertically more than once. So that's why the purple one, the inverse function, is only half. And that's why our original function, the blue one, must be also cut in half. Okay? Halvesies all the way around here. Does anyone still make sure you plot both of them, the blue and the purple one? Everyone's graphing both of these on the front page, at the bottom of the front page. Real quick. Notice the domains, okay? Both of them start at 0 and go either up forever, to the right forever, to this domain. So we're going to be doing all that on the back side here in a second once everyone gets this down. So I'll give you a minute. Make sure you plot them all. Write down all this stuff, please. Real quick, because we're doing them brand new. So, as quick as you can. All right, y'all ready for the back? Here we go. All right, I want everyone locked in, okay? I don't want you to get this wrong on 5.2, so you got to know it now. Ready? First things first, can you take this graph and give me a table? What are the steps to take this equation and get a table? Okay, y'all have yellow calculators on your desk, right? And you're able to type it into graph and press Control-T. Let's just show that real quick. So what is it, x squared minus 3? I'm going to take this over here. I'm going to do a new document, add a graph, x squared minus 3, enter. So everyone can graph it like this. And then you press what? Control T. Now here's the issue. Sometimes you have to move up or down, okay? So look at example 1, okay? Do you see how the domain says 0 to infinity? So I want my graph to start at 0 and go to the right to infinity. Now does my table start at 0 right here? It does not. So you have to actually move your table up or down to find the value you're looking for, okay? So I'm actually going to start with 0, negative 3, 1, negative 2, 2, 1, 3, 6. Does everyone see how that domain on your notes that says 0 to infinity makes you have to go up to 0? Okay. So let's go ahead and start filling in this right here. Here we go. So our original table looks like this. 0, negative 3, 1, negative 2, 2, 1, and 3, 6. Let's write that down. You know how to get it, right? Calculator, Control T, table. Okay. Then, can't you plot those points off to the side here? Let's go ahead and do that too. We've got the table, plot the points. Now, real quick. I'm surprised people got this wrong on the first quiz. What do I do to this table to get the new table? Does everyone know you just flip this table to get the inverse? And you literally just all the way down, switch it around. So in theory, couldn't you flip it and plot the new points and get your inverse graph already, right? That would be totally fine to do, okay? But before we get there, we're going to actually do the equation. Now, the equation is like what we did 5.1. Some of us maybe never did 5.1, or maybe we didn't understand it. So I'm going to explain the 4 steps right now on how to find an inverse function. This is where I want you to be very focused. Everyone looking up here, not your phones, nothing else. Okay, here we go. First step, when you're trying to get an inverse function from an equation, this f of x needs to turn into what letter? A y. Everyone learn this right now. F of x turns into a y. Go ahead and write this down. So this is really y equals x squared minus 3. Okay. Step 1, turn it into a y. Step 2, what do I do with x and y? Switch them. Every single time we do inverses, you have to switch x and y. Okay? Does everyone hear me say this? So step 2, take the y and the x, switch places. So the y turns into an x, and the x turns into a y. Go ahead and write that step. That's step 2. Every time, step 2, x and y switch. Okay? Okay, now step 3 is what we did on our warm-up. Can you solve this for the letter y? We just did it on our warm-up, so hopefully we didn't forget that, okay? Let's think about this. If I want to solve for y, what do I need to get rid of first over here? The squared or the minus 3? Which one goes first? The minus 3, because that's the loner, okay? What's the opposite of minus 3? Plus 3, yeah. So here we go. We're going to put plus 3 on both sides. Plus 3 here. Plus 3 here. It cancels out on the right. So now I just have y squared. And on the left, it's x plus 3 next to each other, okay? Now remind me from our warm-up, how do I get rid of the squared on that y? The opposite of square, square root, okay? So put a square root sign on both sides to get the y by itself. So square root of this and square root of this. The square root and the square cancel out. now I have square root of x plus 3 on this side. You don't really need those parentheses, but it's fine. So step 3 was solve for y. Did we solve for y? Y is by itself. We're good. Okay. Now, last step. We always put the right function notation, and it's an inverse, so we put it like this. F inverse of x equals square root of x plus 3. So y comes to the left side as an inverse function. Square root of x plus 3 goes to the right, the way it was. Okay. That, my friends, is the inverse function. It's the same 4 steps that we did on 5.1. F of x turns into a y. Switch x and y. Solve for y. Write it as inverse function notation. Okay. At least you have this to look at when you get to have to do this on your own on 5.2, right? Now, what can we do to get that inverse table? You could graph this and hit Control T, or you could just flip the original one. Let's just flip the original one. Ready? Boom. Bam, 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 bam. Okay, so again, flip the table and then plot the points. So you got to plot both graphs for me, please. It should be symmetrical across the diagonal line y equals x. And our new domain of our purple one, did you finish the quiz? You doing notes? Okay. Make sure you're graphing it. Okay. So, see the purple one? It starts at -3 on the left side. It goes to the right forever. So we put -3 infinity for my domain right here. Okay. And that is one problem. Okay. I know it's got a lot of stuff, but the main part is you're flipping and doing stuff. So all of those stuff. Yeah. Try to come back quick. Got it. 2 more minutes. All right, let's do the next example. Is everyone done with example 1? Okay, example 2, same idea. Now, I know you can graph this. I know you can press Control T, right? You can get the table. Notice the domain says you want to start at 4. So will you be able to graph, Control T, and go down to 4? Okay, don't start at 0, don't start at 1, start at 4. So I'm going to give you the table here. Go and write this down, and go ahead and plot those points, okay? I know you can do it. We talked about it many times. Just remember, because the domain is set, you have to start at the number 4, okay? Go ahead and do that. And if you want to get ahead, you can do the other table, flip it around. You can already plot the other table. This one? Kind of. You already doing this? Oh, nice. Make sure you do the square root before you do this adding 4. Okay, cool. Okay, so everyone should have the table and the graph, right? Don't forget to graph it, know what I'm saying? Now, let's go ahead and do the equation. First step, f of x becomes what letter? What does this become? Y. Yep. So y equals x minus 4 squared. All right. Step 2. What do I do with x and y? Switch them, right? So y becomes an x becomes a y, so now I'm going to put x equals y minus 4 squared. Okay. Step 3, we need to solve for y. What do I get rid of first? Is it the 4 or the squared? What do you think? Okay, so the 4 is stuck inside. Can't mess with it. Let's get rid of the squared. What's the opposite of squared? Square root. Okay. Now, it's going to look like this. Square root of this, square root of this. Cancels that out. So now I have square root of x equals y minus 4. And how would I get rid of that minus 4? The opposite of that minus 4 is plus 4 on both sides. Plus 4 here. Plus 4 here. And it's going to go after the square root sign. Okay. So the plus 4 and the minus 4 cancel out. Plus 4 goes after the square root sign, not underneath it, but after it. Okay. And then your last step would be to write it in inverse function notation form. Okay. So we're on the back, number 2. Now here's the deal. I had my original table. I can easily get the inverse just by flipping it and then plotting the points. So we should do that. Flip it, plot the points. Whoop, too much. So this flips to this, this plots to this. And you can see that it's reflecting or symmetrical across this diagonal line, y equals x. The one thing that I think might trick y'all or be challenging is this new domain. Now, I know it just popped up there, but how did I get this new domain? Well, look at the purple graph. How far to the left does it go? Well, here, it's not 4, it's 0 to infinity. 0 to infinity. Always look at the x-axis when we're talking about domain, okay? So it's 0 to infinity on example 2. Okay? So make sure you got example 2 down, especially that second table right there. Yeah, if you weren't right there, I wouldn't see it. Everyone should sit in the front row, right? There's only like 6 of y'all. It should all be right here, right? All right. That is example 2. Now we've done 2 examples of it. The third example is just like, okay, hopefully I get it by now. Hopefully you get it by now. You know what I'm saying? You plug it in the calculator, you get the table, you flip the table, you plot the points, you solve the equation, okay? So your assignment is going to be based on that. But I am going to put on the board the third example. If you want to just copy it down, it's going to be the same idea, okay? Once everyone's done with example 2, who's still working on example 2? Okay, here's 3. This is probably one of the more difficult ones, but we did it on the warm-up, actually, on how to solve this, right? So I'll let y'all get that down while I pass out the assignment, okay? The assignment you may not have much time for, which is fine. You'll have tomorrow, but you should start today.